Welcome to the deep dive. Today, we're going to navigate the rapidly evolving world of data quality. We'll peel back the layers, really try to understand how AI is transforming it. Join us as we dig into some, well, pretty fascinating insights, hopefully cutting through some of the noise around a topic that, let's be honest, was seen as pretty manual for a long time.
Yeah, our mission here is to explore how AI is fundamentally changing data quality management. We're talking about moving it from that, tedious manual grind to something much more intelligent, adaptive, maybe even self-driving. We've got some great stuff to unpack for you.
Absolutely. And that transformation is really the core of it. I saw a quote from a chief data officer, I think at an enterprise analytics group, who put it really well. They said, data quality used to be a manual checklist. With Snowflake native AI agents, it becomes autonomous, intelligent, and adaptive to change. And that shift, from a static list to this adaptive intelligence, that's really what we're diving into today. Okay, so to really get why this is such a big deal, we probably need to remember the old days, right? Yeah. Think back a bit. Data quality used to be this incredibly painstaking manual thing. We've probably all been there. Staring at spreadsheets, trying to spot errors, wondering if NUR and New York are the same, sometimes just throwing your hands up.
Oh, yeah. Endless SQL roles, carefully crafted checklists.
A lot of just human slogging through it.
Exactly. So given that context, that historical pain point, what was the real objective behind creating this AI-driven data quality agent within Snowflake? What problem were they really aiming to fix?
Well, the main goal was definitely to go way beyond those, let's call them traditional checks you mentioned. Things like just, looking for null values, checking for uniqueness, spotting obvious outliers. Those basic checks are still needed. Don't get me wrong, they're foundational and they're part of this agent too. But the real leap, the exciting part, involves using these more sophisticated AI techniques to solve deeper, much more subtle data quality problems. The kind that manual rules just, well, they often miss them or take ages to find.
Okay, let's unpack that. We hear AI thrown around a lot. What's genuinely new and different here? What are these sophisticated techniques that are supposed to make such a difference?
Right. So like I said, the basics are still there. Nulls, uniqueness, pattern matching, constraint violations, that's the foundation. But here's where the AI really starts to shine. First off, fuzzy matching.
This agent uses something called Soundex matching. It's basically a phonetic algorithm. So, put simply, it helps spot records that likely refer to the same thing, even if they're spelled a bit differently.
Ah, like the classic John versus John example.
Exactly like that. It sees those as probably the same person based on how they sound. And this isn't just about tidying up names. It fundamentally changes how you reconcile different data sources. Problems that used to be almost impossible to solve manually, you can now tackle them at scale. It's a huge deal for data integration.
Okay, that makes sense. What else?
And then we get into semantic drift detection. Now, this is a massive leap from just checking the structure of data.
Semantic drift.
Sounds complex.
What is that exactly?
It refers to subtle changes in the meaning of your data over time, not just its format, but what it actually represents.
Wow.
So this agent handles that using vector embeddings. Think of them as like unique numerical fingerprints for rows or columns of text data. They're generated using a function like Cortex that embed text in Snowflake. The agent then compares the current embeddings for your data to historical ones, like a baseline. So if the underlying meaning of a data point or even a whole column subtly shifts, maybe say a sales territory description starts including new types of clients.
Even if the text looks similar.
Exactly. Even if the words look consistent, the meaning has changed. The agent flags this because its vector embedding has drifted from the baseline. This really redefines clean data, doesn't it? It's not just structurally sound. It consistently means what you think it means. It prevents those subtle, dangerous misinterpretations.
Wow. Okay. That's definitely going deeper than just checking for nulls.
For sure. And then there's the role of large language models, LLMs, specifically Snowflake Cortex here. What's really powerful is they're not just finding issues, they're also used for auto-rule suggestions and root cause explanations.
Suggesting rules. How does that work?
Well, the agent observes patterns in the data, and based on those patterns, it can actually suggest new data quality rules you might want to implement. It sort of learns as it goes.
Okay, that's smart. And the explanation part.
Yeah, so when it does flag a violation, it doesn't just give you an error code. It uses the LLM to generate a natural language explanation. You might get something like, hey, outlier detected in the amount field. Looks like it might be due to unusually high transaction volume. Probably needs a human to check it out.
Ah, so it tells you why it flagged it. That's much more helpful. Builds trust, I imagine.
Exactly. It moves beyond just saying error to explaining the potential reason. Super important for adoption. And one last crucial piece, the feedback loop.
Right.
Users can actually validate or reject the agent's findings. Say, yes, this was a good catch, or no, this is actually okay. And that feedback directly trains the agent, improving its precision over time. It gets smarter.
So it's like a continuous learning cycle.
Mm-hmm.
The humans guide the AI.
Precisely. It's designed to be a continuously self-improving system, like a digital apprentice learning on the job.
That's genuinely fascinating, a self-improving system. But, real-world data is messy, right?
Mm-hmm.
Are there common, like, pitfalls or challenges people run into when trying to get that feedback loop working well?
Right.
Or just getting the AI trained effectively at the start?
That is a great point. One common challenge is definitely getting consistent and timely feedback from the actual users, the data stewards or analysts. If the feedback is, patchy or slow, the agent's learning curve might flatten out a bit.
Makes sense. Needs regular input.
Yeah. And there's also the initial cold start issue. Right at the very beginning, before it's learned much, you might still need some manual tuning, especially for really complex or unique data sets.
There's a bit of setup involved.
A bit, yeah. But the system's designed to get past that phase pretty quickly once it starts getting even a little bit of user guidance.
Understood. So, okay, for the listener trying to picture this, how does it actually operate? Like, technically?
Yeah.
How is this agent built and deployed inside Snowflake? Is it like a whole separate thing you bolt on?
No, not at all. And that's a key design principle, actually. The expectation is that this agent is entirely Snowflake native, meaning no external compute resources are needed. It runs completely within your Snowflake account. It leverages Snowflake's own building blocks, things like Snowpark for the flexible data processing logic,
Okay.
streams and tasks for automating the workflows, making it event-driven, UDFs, user-defined functions for any custom bits of logic you might need, and of course Snowflake Cortex for all the AI capabilities, the embeddings, the LLM explanations, and things like vector index, which makes those semantic similarity searches really fast. It all lives inside Snowflake.
Got it. So it leverages the platform itself. Could you maybe walk us through a simplified, pipeline?
Yeah.
Just to get a feel for the flow.
Sure, absolutely. Let's imagine a basic sample pipeline logic. First, it would probably scan the metadata, figure out what tables and columns to check based on its configuration.
Yep.
Then it runs those foundational checks we talked about, calculating null percentages, checking uniqueness, things like that. Next step, it might apply the fuzzy matching, maybe using that Soundex function on, say, customer name columns.
Right.
After that, it performs the semantic drift checks. This involves generating those vector embeddings using cortex.embedText and comparing them against a stored baseline. All these results, the basic checks, the fuzzy matches, the drift scores, feed into some decision logic. It scores the potential issues and decides what to flag.
And then if it flags something.
Right, if an issue is flagged, then it uses something like cortex.complete, the LLM function, to generate that natural language justification, explaining the likely cause and impact, like that outlier detected amount example.
Gotcha.
And finally, it logs everything, all the results, the flags, the explanations, and can send out alerts to the right teams or systems.
Okay, that flow makes sense. It sounds incredibly powerful, but, with AI making decisions about data quality, that brings up trust, right? And security. How does this agent make sure it's secure? And how does it maintain transparency so people actually, believe what it's telling them?
Yeah, you're hitting on absolutely crucial points. Trust and governance are paramount. You can't just have a black box. So the agent addresses this in several ways. First, security. It fully integrates with Snowflake's standard role-based access control, RBAC. So you control who can run it, who can configure it, just like anything else in Snowflake.
Standard Snowflake security. Okay.
Exactly. And for sensitive data, maybe PII, it uses tag-based controls. So you can apply masking or specific rules only to columns tagged as sensitive.
Makes sense. What about transparency? Seeing why it flagged something.
Right. For transparency and auditability, it maintains data lineage for flagged records, so you can trace an issue back to its source data. It also uses version logging, keeping a clear audit trail of every check run and every decision the agent made. You can always go back and see what happened. But maybe most importantly, there's an explicit explainability requirement built in.
Ah, the LLM explorations again?
Yes. All the machine learning and LLM results must include the reasoning and the context behind the finding. It's designed not to be a black box. The goal is to build trust by showing its work, basically, giving users the clarity they need to understand and then act on the findings.
Okay, that's good to hear.
Yeah.
So ultimately, for our listener, the big question is probably, why does this matter? What's the real, business impact? Moving from the old manual ways to this AI-powered approach, what's the payoff for an organization?
The impact is pretty significant, and it hits on a few different levels. First, the obvious one, a huge reduction in manual effort. Less time spent writing and maintaining hundreds, sometimes thousands, of custom SQL data quality rules.
Frees up data teams, I guess.
Exactly. It lets them focus on more strategic, higher value work instead of just rule maintenance. Second, and this is critical, it directly helps prevent bad data from polluting your downstream systems. Think about your machine learning models, your critical BI dashboards.
Garbage in, garbage out, right?
Precisely. This acts as a much smarter gatekeeper, protecting the integrity of your analytics and, ultimately, your business decisions that rely on that data. And third, going back to that semantic drift idea, it enables a truly semantic understanding of data changes, not just syntactic.
Knowing the meaning hasn't shifted.
Right. Knowing the meaning is stable, even if the raw data looks okay on the surface, this builds immense trust in Snowflake as that central system of truth. Everyone can rely on the data more confidently.
That makes sense.
And sort of wrapping it all up, it really lays the foundation for what people are calling a governed AI-first data estate. As companies use more AI everywhere, ensuring the foundational data is clean, accurate, and trustworthy becomes absolutely non-negotiable. This helps build that governed foundation.
Yeah, you see how that becomes table stakes. And just to underscore how fast this is moving, I noticed the source material even touched on potential future extensions. Things like supporting real-time streaming data quality checks with Snowpipe, or maybe integrating checks for PII protection, shows that this isn't just a one-and-done thing, right? It's evolving.
Absolutely. It's a very active space.
So quite a journey we've taken today. We've really explored this shift in data quality management, moving from that manual, checklist-driven chore
Yeah.
to something autonomous, intelligent, self-improving, all powered by AI within Snowflake. We've seen how it blends those necessary traditional checks with really cutting-edge AI, the Soundex fuzzy matching, the vector embeddings for semantic drift. It's all about building a more reliable, more trustworthy, and more adaptable data foundation for everything else.
Indeed. And it makes you think, doesn't it? If these AI agents can get this sophisticated, this good at self-correction in something as nuanced as data quality, what other complex areas of running a business might be transformed next by this kind of continuously adapting, self-improving AI? It really pushes you to consider the broader implications, Where else could these autonomous capabilities make a difference as they learn and evolve alongside our data?
That is definitely a thought-provoking question to end on. Where else could this go? Well, thank you for joining us on this deep dive today. Keep exploring, keep questioning the world of data and AI, and we'll see you next time on The Deep Dive.